show you, now that you've tried it on your own, let's see if you got these correct. So these are trickier Lewis dot structures. So let's look, for example, at oxygen. And the important thing for you to know when you're doing these is you really need to follow these steps, or else you're going to end up getting the easier Lewis structures wrong, because you're going to end up confusing yourself. So really make sure you're paying attention. So if I give you O2, remember your first step is to determine the number of valence electrons. So that would be 2 times 6, which gives me 12. Okay. My next step, again, remember we're going to share electrons. Okay. And I'm going to add my lone electron, so everyone has 8 valence electrons. And now I'm going to count. Okay, so let's count. So I have 2, 4, 6, 8, 10, 12, 14 electrons I'm using, but I only should be using 12. This is the only point where once you've filled in your Lewis structure and you realize you're using too many valence electrons, this is the only point where you should do what I'm about to do. If it works, right, always do it, check if you have the correct number of valence electrons. Do not do what I'm about to do. Only if you're using too many valence electrons, which I am right now. I'm using 14. I need, instead of just using one bond, I need to have oxygens share another pair of electrons, because if you look, if they now share 2 pairs, that means both oxygens have 4 electrons right now. So I'm going to add 2 more, so that's 8 electrons total. So now I'm using 2, 4, 6, 8, 10, 12 valence electrons, which is how many I want to use. Okay? So only in a situation where you've filled out the Lewis structure, you're using too many valence electrons in order to make sure everyone has that perfect octet, only then should you use a double bond. And as a hint, eventually you might also have to use a triple bond, but only use a triple bond if I filled this out, I was still using too many valence electrons. Do not just blindly add triple bonds. That's what a lot of students like to do. Start off with the same steps that we did before. When you do your final count, if it doesn't work, then you can try a double bond. Okay, so let's look at one more example. If I gave you SO2, okay, so let's figure out valence electrons. So sulfur has 6 valence electrons. Oxygen has 6 as well, but there are 2 of them, so that's a total of 18 valence electrons. Okay? So I'm going to share electrons, and I automatically draw it like this simply because I'm pretty sure they're going to be lone pairs of electrons here. So I know that that's going to force the oxygens downwards based on your VSEPR model. So I drew it like that. Okay? I'm going to make everyone happy. And then sulfur right now has 2, 4, so I need 6, 8. Okay. So now I need to count. I'm using 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I'm using too many electrons. So now, and only now, can I use a double bond. So I'm going to use a double bond. So I'm going to draw this. I'm going to put the double bond on the left-hand side. And I know the question is going to come up. Just give me 1 sec. I've got 4 electrons on this oxygen, so I'm going to add 4 more, so 2, 4. I've got 2 electrons here, so I'm going to add 6. And then I have 2, 4, 6 here, so I'm going to add 1 lone pair here. Notice it still is going to have that bent-looking shape simply because I've got that lone pair of electrons here. So I know the question is going to be, well, how do you know where to put the double bond? Well, you don't. So this is an example of what we call resonance. Okay? So what actually exists is not this. I'm going to draw a double arrow to show that this other thing can exist. I'm going to put my double bond on this side. So put it on the opposite side. And the question I'm sure is going to be, do I have to draw both versions of this? The answer is yes. And if we had 3 different ones and just one double bond, you have to draw the double bond on top, bottom, and to the left. So you'd have to draw 3 different versions. Now, this is resonance. And the important thing for you to know is that neither of these actually exist. What actually exists is an average of these 2 molecules. So specifically, if, for example, this were, let's say, yellow, the color yellow, I'm just creating an example to help you understand this, and this were the color blue, what would actually exist for SO2 is not yellow and blue. Instead, what would actually exist is the color green. Okay, so in AP, we look at this much further. All you need to know is that you need to draw both of these versions of resonance because actually what exists is an average of the two of them.